Hello, students. Today we are going to learn correlation, that is chapter 7 of statistics. Now, see, in the previous chapters, we have learned about how to construct the summary measures out of mass of data and the changes among similar variables. And now we are going to learn how to examine the relationship between two variables. Like, let's say, for example, now, whenever there is too much of summer or as the summer heat rises, hill stations are crowded with more and more visitors. Ice cream sales becomes more brisk. Thus, the temperature is related to number of visitors and the sale of ice creams. Similarly, as the supply of tomatoes increases in your local market, its price drops. So when the local harvest starts reaching the market, the price of tomatoes dropped from a price, let's say 40 rupees to 4 kg or even less. So thus over here the supply is related to price. Now, correlation analysis is a means for examining such relationship systematically. So it is dealing with the question like, is there a relationship between two variables? So correlation is a linear association between two random variables, and it analyzes or shows us how to determine both the nature and strength of relationship between two variables. So when the variables are dependent on time, correlation is applied. So correlation lies between +1 to -1. Now, talking about the various types of correlation, a zero correlation indicates that there is no relationship between the variables, and a correlation of -1 indicates a perfect negative correlation, and correlation of +1 indicates a perfect positive correlation. Now, when we talk about the types, type 1, type 2, and type 3. So, when we talk about type 1, we have positive correlation, negative, no correlation, and perfect correlation. So, if two related variables are such that when one increases or decreases, the other also increases or decreases. And if the two variables are such that one increases, the other decreases if both the variables are independent. In type 2, we have linear and non-linear. Now, linear correlation is one when plotted on graph, it tends to be perfect line. Whereas non-linear is when plotted on a graph, it is not a straight line. In type 3, we have simple correlation, multiple, and partial. So simple correlation is the one wherein two independent and one dependent variable. And in case of multiple correlation, one is dependent and more than one independent variables. Whereas in case of partial, one dependent variable is existing and more than one dependent variable, but only one independent variable is considered and the other independent variables are considered constant. Now, when we talk about the methods or the techniques for measuring correlation, there are three important statistical tools which are used to measure correlation, and they are scattered diagram, Karl Pearson, and we have Spearman rank correlation. A scattered diagram visually presents the nature of association without giving any specific numerical value. So a numerical measures of linear relationship between two variable is given by Karl Pearson coefficient correlation. And a relationship is said to be linear if it can be represented by a straight line. When we talk about Spearman coefficient of correlation, it measures the linear association between ranks assigned to an individual item according to their attributes. Now, attributes are those variables which cannot be numerically measured, such as intelligence of people or physical appearance or honesty, etc. Now, when we talk about scattered diagram, it is a useful technique for visually examining the form of relationship without calculating any numerical value. And in this technique, the value of two variables are plotted as the point on the graph paper. So, from a scattered diagram, one can get a fairly good idea of the nature of relationship. And in a scattered diagram, the degree of closeness of scattered point and their overall direction will help us to examine the relationship. Now here we can see the first diagram on the left. That is an example of positive correlation. The second one is example of negative correlation. Then we have no correlation, wherein we can see on the left hand side bottom, we can see that there is no correlation because all the points which are plotted are scattered. And then we have perfect positive correlation and perfectly negative correlation. So after scattered diagram, now let's study Carl Pearson's coefficient of correlation and interpretation of correlation coefficient. So the method of correlation was, as I said, it was developed in 1885, and it is the relationship between two sets of scores or variable. So whenever two variables of the same group are so related that the increase or decrease are correspondent to the increase or decrease to another. Now, when we talk about types of correlation, as mentioned earlier, we have positive, negative, and zero correlation. So, if when the first variable increases or decreases, the other also increases or decreases respectively, and their relationship is said to be positive because they move in the same direction. Like, let's say, for example, intelligence and achievement. Now, in case of negative correlation, if when the first variable increases, the other decreases. And if one decreases, the other increases. So here it is said to be negative correlation because they are moving in the opposite direction. Like let's say, for example, anxiety and performance. Now, if there exists no relation between the two sets of measures or variable, then it is called as a zero correlation. Like let's say intelligence and height. So there is no relationship between the two variables over here, which is known as zero correlation. Now, when we talk about coefficient of correlation, the ratio which indicates the degree of relationship between the two variable. So for a perfect positive correlation, the coefficient correlation is +1. For negative, it is -1. For positive coefficient of correlation, it varies from 0 to +1. And for negative coefficient of correlation, it varies from 0 to -1. Now, correlation will help us to determine the validity of the test, and it helps to determine the reliability of the test. It also indicates the nature of relationship between two variables and to ascertain the traits and the capacities of the pupils. Now, there are two different methods. One is a rank different method and the other is product moment method. Now, product moment method, which is also known as Carl Pearson's method, it is most widely used measure of correlation. And this method, as I said, it is also known as Pearson's product moment method in honor of Carl Pearson, who is said to be the inventor of this method. The coefficient of correlation computed by this method is known as the product moment coefficient of correlation or Pearson's correlation coefficient, which is represented as R. So this is the formula which is used in computation of this method. Now when we apply this formula, n is the total number of scores or cases. Sigma is the summation of the items which are indicated. Sigma x is the sum of all the x scores, and x square, each x score should be squared and then those squares are summed. So the sum of x squared scores, and sigma x scores should be summed and the total squared. Whereas sigma y is the sum of all y scores, and sigma y square is each y score should be squared and then those squares are summed. Sigma y whole square is y score should be summed and the total squared. So here is the example wherein we are given the subjects, scores in test 1 and scores in test 2. So we have A, B, C, D, E. That is N is 5. The scores in test 1 is X. Scores in test 2 is Y. Now when we multiply X and Y, we get XY. When we have X square, we have to double X and Y. Here is the result. So N is 5. The total of X is 24. Total of Y is 66. XY is 315. Sigma X square is 138. And sigma Y square is 914. Now we have to apply all these data into this formula. And the answer which we get is this. So the product moment correlation coefficient is minus 0.0576. Here is another example. Same way, we can calculate. We have A, B, C, D, that is N is 5, and so on. Apply it into the formula, and then we get the answer. Now, when we talk about interpretation of correlation coefficient, the value R or the R value was verbally interpreted as per the criteria suggested by Garrett in 2010. The details are as below, which is not in the syllabus. So the advantages of this product moment correlation is that it gives us precise and quantitative figure which can be interpreted meaningfully, and it helps in establishing the value of the dependent variable from the known value of independent variable. And when we talk about the limitation, this method assumes that there is a linear relationship between the variables under the study, regardless of the fact whether it exists or not. And compared to other methods, the computation of correlation coefficient by this method is time consuming. The value of coefficient is unduly affected by the extreme items. Thank you.